So I guess they'll ask me on that.
Okay. Yeah, they can ask you anything like in the probability section. They can ask you like, first of all, you must do your past year, like not the past year, but the exam
Right.
paper very well, okay, from top to bottom, and they can ask you questions from their number one. Okay, so you told your interest is probability and combinatorics. Let me like think about a problem. I cannot turn on my video right now. I'm sorry for that, but I will try
Sorry.
to do that in future for other interviews.
I also have a pen and a notebook,
Yeah,
just
you
in
will
case
be
I need.
needing that. They will be in that in the interview. They will be having a blackboard, so you will be standing in front of a blackboard
Okay.
and not sitting without earphones. So the life will not be comfortable over there. Anyways, so coming to your probability question, let's think about this problem. Can I define what is you know multivariate normal distribution?
Yes. So one of the most insightful ways of thinking about a multivariate normal distribution is that a normal distribution is basically a linear distribution. That is the best way to think about normal distribution. That is, the means get added for independent normals and the variances get added for some of independent normals. So the multivariate normal distribution, in essence, is a way of having a vector of normals such that the sum of all of these normals gives you another normal. This is not always the case because you can have situations in which the sum of normals is yet not normal.
Wait. I asked you to define multivariate normal. So you're telling me properties of multivariate normal.
This is because the motivation for having a multivariate normal
I didn't
is
ask you for a
that
motivation. I asked you for the definition.
the definition of a multivariate normal is that it is the probability distribution of a vector of variables, each of which follows a normal distribution and has a given correlation among each.
Okay. Okay. Fine. So what is a bivariate normal distribution? What is a bivariate normal distribution, Aditya?
A bivariate normal distribution is a multivariate distribution which has only two vectors, x1 and x2, and each of which follows in the marginals of which each follow a normal distribution. And these two distributions, x1 and x2, are correlated among each other by a given correlation coefficient.
So you're telling if you have a normal, let's say five normal distributions, and they have some correlation, they will together form a multivariate distribution. It's an if and only if condition. Like that's how you define multivariate normal distribution.
No, the condition is that if these distributions, if these normal distributions themselves add up to provide a normal distribution, a new normal distribution. We can take linear combinations of any of these normal distributions, and we'll get another normal distribution. It is not if and only if. It is if this condition holds, then the distribution, then these vectors will be said to be in a multivariate normal distribution.
Okay, let's say this is not a workable definition, right, Aditya? So how can you find the expectation of, let's say, 5x plus 3y plus 9z? So how will you find the expectation of that?
For given that x, y, and z are normal distributions,
X comma y comma z are multivariate normal, follows multivariate
and we are
normal.
given the parameters of this
So that's
multivariate
not,
normal distribution.
I didn't get you what are the parameters, so you didn't define it well, right? So you see, these are the normal questions that came up. So what is the definition of multivariate normal?
The marginals of them are themselves normal with a given mean and a given variance.
Okay,
So you have x, y, and z. The marginals of this will follow a normal distribution themselves.
so when you define any distribution, they have some parameters, right?
Right.
So what are the parameters of multivariate normal?
The parameters of the multivariate normal are obviously you have the distributions themselves, uh, the marginals themselves. You have the marginal parameters which are x1, x2 to up till xn. You have their means, so
So
mu1, mu2
you
up
have
to
forgotten
n.
the definition of multivariate normal. Okay. Anyways, it's fine. You should revise that.
Okay,
So in the exam hall, if you kind of face this scenario, like try to not to like tell them blatantly that sir I have forgotten. Okay. So don't try to deviate like in make out stories, because if the one knows how to define or distribute a random variable, okay, so there is no alternate definition or you cannot start with properties. So
fine,
anyways, so the professor will be angry because you have wasted their time, nothing more, okay.
right.
So okay, anyway, so the number one thing is that you should be remembering all the definitions very well, okay, all the definitions of probability, statistics, linear algebra, whatever. Also, a multivariate normal is a a multivariate distribution with joint random variable with a certain given a structure, right? So you have to write that on the board. And the parameters you write mu vector and let's say
Covariance matrix.
yeah variance covariance matrix. Yes. So you have to write these things. Okay.
Okay,
So yeah. So this is number one. So remember the definition. That's why I started with that, because people have know how to solve problems, but they don't know a definition.
right,
Okay.
right.
So problem solving strategies are not gonna work always. So this is the thing they try to focus on, okay, in the interview. Okay, so let's say you have fixed, you have taken three vectors, three trivariate normal vectors,
Okay,
okay, and let's say it's a trivariate, standard trivariate normal, okay,
okay,
like they have zero correlation and their variance is one, mean is zero, okay, all of them.
okay, okay.
So it's like 0 comma 0 comma 0 vector is the mean vector and the standard, and the variance covariance matrix is the I.
Yes. Yeah, I like.
So the question is that you take three realizations of this trivariate, standard trivariate normal, okay? Let's say V1, V2, and V3, right? So these three are vectors, right?
Yes.
So my question is that what is the probability that the dimension of the span of these three vectors is 2?
Probability span of these vectors is 2. Okay,
Write it down in a copy, think about it.
okay,
So V1, V2, V3 are three trivariate standard normal distributions, random normal variables. What is the probability that the dimension of this, the span of these three vectors is 2? I hope it's fine if I give this recording to the students. Is it fine
yeah,
with you?
it's fine, it's fine.
Sure. Because they will
Take,
understand the main point, okay?
right, right. We take three realizations, right?
We get
You take, you said we take
three
three
realize,
realizations, right, right,
three vectors, yeah.
right. Okay,
So what are you thinking?
Yeah, yeah. So my thinking is that if we are given the span of the uh,
Three vectors.
matrix, yeah, the span of the matrix, which is given by three vectors that we have created, is two,
Yeah.
which means that if you write this down as a matrix, B11, B12, B13, B21, B22, B23, and B31, B32, if the span is two,
The span is not two. The rank is two. You can say the dimension of the span of
yeah,
the
right,
two vectors is two. Yeah.
right. So that means that uh, basically one of these vectors can be expressed as a linear combination of the other two.
Yes.
So we can so basically we can say that B31, which is the first realization of B3, B32, which is the second realization of B3, and B33, which is the third realization of B3. All of these can be expressed as a we can say it is equal to K1 B1 plus K2 K1 B1 plus K2 B2 for all three of these realizations.
Yeah.
So what we are asked to show is that what is the probability that B3, which is itself just a standard normal, is equal to uh, K1 B1 plus K2 B2,
Okay. Yeah. You're on the
and
right track.
because these are independently realized, because we take three independent realizations, we just have to take this has to hold three times over.
Okay.
So what we are asking is the probability of B3 is equal to K1 B1 plus K2 B2 Q.
Okay.
Now, the probability that uh, B3 is equal to K1 B1 plus K2 B2, we can only get a density like to get the probability of B3 is equal to K1 B1 plus K2 B2, given that these are all independent. Yeah. So what we'll get even if we integrate, we'll get a density rather than a probability. Because the probability that B3 is equal to exactly K1 B1 plus K2 B2 is going to be zero.
Yeah.
Yeah. So so my answer to this question is that we can calculate the probability like we can calculate TV3 is equal to K. We can calculate density for this, but we cannot calculate a probability because it's going to be zero.
Okay. Why is the probability going to be zero?
Because the probability that B3 is equal to even for let let's just simplify to simpler case, a univariate case. Probability of B3 is equal to KB1, KB1, or probability of B3 is equal to KB2.
Mm-hmm.
The probability of this happening is basically the if we consider it in Cartesian plane terms, we are basically asking the probability that of a line upon an area, which is always going to come out to be zero.
No, no, wait. Like, who told the probability on a line will be zero?
We have to evaluate the uh, no, like if we consider a very simple problem of what is the probability that x1 is equal to x2.
X bar is equal to.
No, it's a problem that probability of vector 1 is equal to vector 2, a simpler case of this problem.
Yeah.
We consider that, then we observe that this is just we can visualize this as being we have to integrate the density of a line basically along the line compared to the whole space.
Yeah. So why on a line the integration will be zero? Think if you can construct the same argument in a different manner. Like, okay, so what type of similar situation you have seen in one dimensional case?
A simpler one-dimensional situation is the probability that uh, the probability of in a continuous variable of having exactly one value, probability of b1 is equal to like zero, for example.
Great.
That is
How can you
always zero.
extend that to this idea? Like, just try to like
Yeah, so we can
explain to
extend
me.
that to this by saying that okay, fine. We can say that let b3 is equal to 0 or b3. Let's just we can condition on the value of b3.
I didn't get you. Can you come again?
Yeah, yeah. So let's try a simple case. P of x probability of b1 is equal to b2. For the simpler case, we can say that it is equal to the probability of b3 condition on the value of b3. Let's say that b3 is equal to small b3.
Okay.
Now, the probability that b1 is equal to b3 in this example is going to be the probability that b1 is equal to the density of even b3. My God, what am I saying?
Yeah, think about it.
Yeah.
Don't rush. Yeah, write it down properly and think about it. Never rush through in the exam. Okay, I mean while telling. Okay, people rush when they're afraid or they're tensed.
Okay. So express the law of total probability in this fashion. The probability that b1 is equal to b3 is equal
The
to
probability.
that vector 1, that realization of vector 1
Yeah,
is equal to the realization of vector 3,
yeah.
that is equal to the integral of probability of b1 is equal to x, given b3 is also equal to x,
Okay,
times the f probability density function of b3 at x. This we have to integrate over the entire range of values that b3 can possibly take, all the x.
okay,
Now, note here that because b1 and b3 are independent, this
okay,
amounts to just the probability of b1 is equal to x in times the density function of f of b3 x at x integrated over all the values of x that b3 can take.
okay,
And here we notice that probability of b1 is equal to x is actually zero because the probability that any random vector can takes exactly one value, that is always zero.
okay,
So when we integrate this using the law of total probability, we get an integration of zero over the entire space of values that b3 can take.
okay.
And yeah, coming back to the main question. Coming back to the main question.
No, wait. I'm just thinking about this thing that you integrate over the density, not the probability, right?
Right, right. No, yes, we do integrate over the density, but there is also product. We are multiplying the density with the probability that the realization is equal to x or b1 is equal to x. That is
Right? They're independent. They're getting distributed. So what is the you like? You are not ever you not using that, right?
hmm? Yes, we did use that. We took it out of the equation.
So
Probability of
you
b1 is equal to x given b3 is equal to x
No, V1 and V2 are independent, right? So
You said that the correlation was 0, right? And
that's
when the
among the VIs, in the among the coordinates of the VIs. And even if it's given, it's always a density, not the probability, unless it's a discrete one. If x is equal to integration f of x given y times f of y integrated over all the values of y dy.
that should give us a probability density, right? Not a probability.
Yes, that's the probability density, you're right.
The probability, which is what we are interested in, that probability of V1 is equal to V3, that is 0, right?
Okay, so you're saying probability.
Of
Okay,
V1 is equal to V3, that is 0.
let's check. Can you write down the equation again? Can you tell me the equation once again?
Yeah,
Probability V1 is equal to V3.
is equal to
Yeah.
integration over all the values of V3.
Yeah.
Uh, the integrand is probability of V1 is equal to X
Mm-hmm.
given V3 is equal to X
Mm-hmm.
into the probability density F small f V3
Okay, this is
of
fine.
X
This is fine.
of X.
Yeah. Now what's the next step? This is fine. Yeah.
Yeah. Next step is to note that V1 and V3 are independent. We have that they're uncorrelated, and when two variables in an multinomial normal vector are uncorrelated, they're also independent. So we can simply write this as probability of V1 is equal to X times F or density of X at of V3 at X dx integrated over the entire space of values that V3.
Okay, this sounds good. Okay.
And so when you, but probability of V1 is equal to X is 0 at all points
Okay.
because of the property of continuous growth. And
Hmm.
so this entire integration is integration of 0 over the entire space. Which is 0.
Okay. Okay. This is a good solution. But don't you think this solution is too hard to generalize to n end vectors and in case of the arbitrary dimensions? Do you think there's an easier way out? Let's say you take n random vectors from R to the power n.
Yes.
So what is the probability that they will have the dimension of the span will be, or the
N
matrix from
minus 1.
n vectors is not n minus 1, any number, just any number.
Are these matrix, is this vector like independent, like all of these values independent?
They can be independent, they cannot be independent.
Okay. Then it seems like we cannot answer.
Let's take their independent, huh?
Uh, Carry on. Okay, you're
let's take
saying take
their,
the,
let's take their independent. Yeah.
okay. and we have an n cross n matrix, and you're asking what is the probability that the dimension of this is any
Is any
it,
number.
yeah. So I really want to go out on a limb here and say that I feel like if they are independently realized, then the probability that uh, they have full rank should be one. That is, matrix full rank should be one. But I'm not able to figure out a way to prove it.
Think about it. I mean, I should suggest you think about it as you're home. So you understand, like, I will not be able to discuss all the problems out here. That
Right,
so
right,
what I suggest is that for the next student, I will also be recording. I will sharing the video. So and also, if not, then I will sharing the questions. So try to think them and try to answer them in a 15 minutes or 20 minutes
right,
interval. So because
right.
I cannot interact with all the students in so much details, but yeah, I think this should be the idea. I think we should call it we should
Right,
call it over here. So the takeaways are remember the definitions, okay? And don't try to, if you don't know something, tell you don't know. It will save the professor's time, okay?
right,
And because then also it will save the students, the teachers' time because they can ask other questions to evaluate you,
right.
and they are waiting for other students, so that can be a turning off point. Everything is fine. I think it's good to go. And yeah, you think about a better solution to this. There's a one
Right.
line solution to this. So
Okay, fine. I just got it. But is I thinking on the right track? Is it actually
the
one?
idea is correct. Idea is about continuous distribution take zero probability on this kind of sets, but you can actually convert this problem into just one line problem. So that's like
Okay,
really easy. All the best. Try it out. So
thank you.
yeah, all the best, Aditya, for the interview, and also it will be active for the interview till the interview, so you can interact with the students out here. Yeah.
Right, right.
And check
I
out the questions and ask, talk to the students out there what questions are asked, so you get to know the questions also. Yeah.
understand.
All the best. Yeah. Bye.